Alright, so before moving on to the next part of the section, I just wanted to hit something very quickly about delta G and delta G standard and things like that. So what does delta G tell us? The one thing that delta G tells you when you're looking at some sort of process, for example, we have our reaction y goes to x, right? What it tells you is how far away from equilibrium you are and in what direction the reaction will move spontaneously to reach equilibrium. So when you're on this side, where delta G right here is greater than 0, product has to be turned into reactant. So in this case, you know to reach equilibrium, you actually have to turn X into Y. Now, when you're on the other side, which is over on this side right here, right? Well, you have a negative delta G. And what it's telling you now is that the reaction has to take reactant and turn it into product to reach equilibrium. Now, how small or how big the number is tells you how far away from equilibrium the reaction currently is and how far it has to go to reach it. So what else can we find out from looking at delta G's? So let's erase this stuff. Okay, if I am here at equilibrium, right? What do I need to do? How much energy do I have to put in to take more reactant and make product going in this direction? Exactly y goes to x, right? Because you can see here that the numbers, the ratio of x to y is increasing. That means that I have to turn more reactant into product. So if I'm starting at equilibrium and I want to get to a ratio of 100 to 1, I need an input of 5.9 kilojoules per mole. Actually, I need an input slightly larger than that. So the delta G from going from equilibrium of a ratio of 10 to 1 to 100 to 1 is going to be 5.9 kilojoules per mole. So what I need is a second process. Okay, so I need a second process or reaction to be coupled to this that at least, at the minimum, it is slightly less than negative 5.9 kilojoules per mole. What do I mean by less? Like negative 6 or negative 5.911. So when I add these two up, I get a delta G that is less than 0. 0 is not going to be good enough. It has to be less than 0, because if it's less than 0, that means that the one reaction that is coupled to the reaction that's unfavorable will kind of power that reaction. Because overall, that means that, okay, I am decreasing entropy, right? So entropy down. This one is increasing entropy. And overall, I'm increasing entropy. So we meet the standards that nothing can happen unless disorder is increased.